Hello students, welcome back to RD Chemistry. Here we'll discuss osmotic pressure connected to the Van't Hoff factor, means for electrolytic solutions how to find out the osmotic pressure, right? Van't Hoff factor is represented by the symbol I. It is calculated as one of the formula is number of particles after dissociation or association divided by number of particles before dissociation or association. Okay, let me give some simple examples for dissociation. Let me take sodium chloride. Sodium chloride is an electrolyte. It can dissociate to give ions, sodium ions and chloride ions. Any substance that dissociate or associate to give ions is known as the electrolyte. Now, assuming 100% is ionized or dissociated, number of particles once is getting dissociated is equal to 2. Initially we are using 1 particle, sodium chloride. 1 mole will give 2 moles of the particles. Therefore, Van't Hoff factor is equal to number of particles after dissociation divided by number of particles before dissociation, which is equal to 1 now, which is equal to 2 in this case. If I take barium chloride, assume 100% is a dissociated or associated. So this will give 1 mole of the barium ion and 2 moles of the chloride ions. Altogether 3 particles are there. To begin with 1 particle, 1 mole. So I is equal to after dissociation 3, before dissociation 1, therefore number of particles are 3. Okay, in case of dissociation, number of particles produced after dissociation per 1 mole per 1 particle, right? Assuming this is assuming 100% dissociation. Now what is association? If I take acetic acid in benzene, suppose I dissolve this in benzene, okay, but if I take water, it will give acetate ion and H plus ion. But if I take acetic acid, 2 moles of acetic acid will combine to give the dimer, acetic acid dimer. 2 molecules acetic acid combine to give single molecule. It's a dimer. Why it become dimer now? Because we have got hydrogen bonding. This is the structure of the acetic acid. One more molecule, acetic acid CH3, C double bond O and OH. There is an intermolecular hydrogen bond between the 2 acetic acid. Therefore, this is known as the dimerization. So, this is the process called the dimerization in the association. Either dimerization, trimerization or tetramerization. Okay, which can also be written as 2 moles of A will give A2. I is equal to, after dissociation, 2 moles will give 1 mole, correct? Or 2 particles will give 1 particle of the dimer. Therefore, 1 divided by 2. This is a 0.5. Got it? If a tetramerization, trimerization, 3A will give A3. Trimerization. For this, I is equal to 1 by 3. Tetramerization is equal to giving A4. Therefore, I is equal to 1 by 4. Okay. So, this is a concept of association. We have to remember here, all electrolytes are not 100% dissociated or associated. Okay. Therefore, it depends on the degree of dissociation association, and thus we can find out the I value. So, I value depends on the alpha degree of dissociation or association. So, there are different formula we'll have to remember. For dissociation, we remember the formula. I'm not going to derive here. So, alpha, the degree of dissociation is equal to Van't Hoff factor I minus 1 divided by n minus 1. And for association, similar formula, association, alpha is equal to I minus 1 divided by 1 by n minus 1. Okay, alpha degree of dissociation or association. I is nothing but Van't Hoff factor. Okay, I is Van't Hoff factor. What is n here? N here is a number of particles after dissociation. Number of particles after dissociation. After dissociation. What is this N stand for here under association? This stand for number of molecules undergoing dimerization, trimerization. If it is a dimerization, dimer N is equal to 2, trimerization N is equal to 3, tetramerization N is equal to 4. Okay, so N values are different. Concept is not same for N value, right? Now, what is the formula for osmotic pressure? Osmotic pressure formula, you know that pi is equal to CRT. This is for non-electrolytic solution. Now for electrolysis, pi is equal, it should be I into C into R into T. Okay, I value should be multiplied to the CRT. This holds good for the electrolytic solution if they undergo association or dissociation. Okay, right? We'll solve one problem. Now read this question. Calculate osmotic pressure in terms of atmosphere. Pi value to calculate. Of solution having a 0.1 molar sodium chloride, 0.2 molar sodium sulfate Na2SO4 and 0.5 molar HA stand for some weak acid which is a 20% dissociated. Alpha is given 20% dissociated. And for sodium chloride and sodium sulfate, they are not given degree of dissociation alpha, which means assume 100% ionized. Okay. Now we have to calculate osmotic pressure of the final solution, which is equal to, it should be I into C into R into T. Okay. But there are more than one solution, solute is mixed here. It's a mixture of solutions now. Okay. There are different types of electrolytes, sodium chloride, sodium sulfate and the weak acid. Okay, now, so therefore this is equal to pi f is equal to, first one I into, let me take C1 R into T, this is for the sodium chloride. Second solution, it's Van't Hoff factor I into C2 into R into T, this for the second solution, sodium sulfate. Okay. Third one is the HA weak acid. For that I into C3 into R into T. This for the HA weak acid which is a 20% dissociated. Now sodium chloride and sodium sulfate both are 100% dissociated. We can calculate I value directly. Correct? So I'll start with the I value calculation for sodium chloride and sodium sulfate. Sodium chloride NaCl gives sodium plus and Cl minus. So I value is equal to, after dissociation 2 particle, before dissociation 1 particle. So 2 divided by 1 is equal to 2. Let me take sodium sulfate, Na2SO4. Na2SO4 gives 2 moles of the sodium ion plus 1 mole of the sulfate ion. Altogether number of moles are 3 particles. Number of moles are 1 here, 1 particle. So I is equal to 3 divided by 1 is equal to 3. But HA dissociate partially to give H plus and A minus. Yeah, now when I write equilibrium like this is not 100% dissociated. Maybe here it is given 20% dissociated. Okay. Now this is a dissociation. We can bring I is alpha is equal to I minus 1 divided by N minus 1. Correct? Right? Or I have to write out the I value. I have to get the I value now. I minus 1 is equal to alpha into N minus 1. Correct? Or I is equal to 1 plus alpha into N minus 1. 1 is fine plus. What is alpha? Alpha is given as the, how much? Alpha is given as the 20%. So we will not be introducing percentage here, but we will be getting rid of the percentage. 20 divided by, I will remove the percentage divided by 100 is equal to 0.2 now. So it is a 0.2 into N minus 1. What is N here? N stands for number of particles that are formed after dissociation theoretically. Okay. So N is equal to 2. Altogether 2 particles are there. So we will be taking theoretical here. This is not the I value. N is not equal to I here. Okay. So this is equal to now 1 plus 0.2 into 1 0.2. Okay, so it is equal to 1.2, right? Now we'll go back to the formula list. So I can write this as, okay, see here RT is the common everywhere, I into C1 plus I into C2 plus I into C3. RT is the common there, right? Now we want the answer in terms of atmosphere. So R value should be in terms of 0.0821. And they mention about the temperature in the question itself 300 Kelvin, correct? So it is a 300 into I value for sodium chloride is a 2, we know that, into concentration of sodium chloride is given 0.1, sodium sulfate 0.2 and Ha 0.5. Okay, so I'll be writing accordingly. So therefore 0.2 into 0.1, this for the sodium chloride, plus I is equal to 3 into concentration given is a 0.2 molar sodium sulfate, and I for Ha is equal to 1.2 into its concentration given as the 0.5. Okay, right? So when you calculate this one, so you're getting final answer is equal to, it is 34.4 comes in terms of atmosphere. Okay, is that fine? Hope this is clear to you. Please do subscribe, share and like the videos. Thank you for watching. Have a nice day.